How's it going, guys? Today we're going to be doing 11.11, parts 3 and 4 from the Continuous and Discrete Time Signals and Systems book. It says, given the following transfer function, determine the unit step response of the system by using the time convolution property of the DTFT. So we're going to start out and say that x of k is equal to the unit step u of k. And to make things simple, we're going to take everything into the z domain. So z is going to be equal to e to the j omega. So we know that x of z is going to be equal to 1 over 1 minus z to the negative 1. H of z is going to be equal to this right here. And using the time convolution property, we know that y of z is equal to x of z times h of z. And we end up getting this equation right here. Now we're going to use partial fraction expansion to convert y of z back into the time domain. And we all know how to do partial fraction expansion. You solve for your four constants a, b, c, and d, and you end up getting this equation right here. Now we're going to use these two properties and solve for y of k, and we end up getting this answer right here. Now for part 4, we're going to be doing the same thing, except we're going to be using convolution sum. From part 1, we know that h of k is equal to this right here, and we still know that x of k is equal to u of k. Now we're going to convolute h of k and u of k together, and we get the sum from m equals negative infinity to infinity of this long thing right here. Now we're going to break the summation up into parts and change the limits, and now we're going to use the geometric property to simplify it even more, and then you can distribute constants and get this answer right here. Let's finally solve for y of k.